Welcome to the second lab in your physical science experience. Today in lab, we will make measurements using a meter stick, a triple beam balance, and a stopwatch. The experiment is subdivided into 6 steps. In the first step, we will determine the least count of the measuring devices and record the results in table 2.1. We will also measure the length and width of the table and determine the area in square centimeter. Then we will convert square centimeter to squared meter. In step 2, we will determine the volume of a wooden block, and then we will determine the volume of a wooden block in cubic centimeter. We will take the measurement of each dimension 3 times and record all significant digits in table 2. In step 3, we will determine the mass of the wooden block in grams. We will use the triple beam balance to record the mass of the wooden block. In step 4, we will determine the density of the wooden block given the formula density equals mass over volume. In step 5, we will express 1 second as a fraction of a mean solar day based on the knowledge that there are 60 seconds in 1 minute, 60 minutes in 1 hour, and 24 hours in 1 mean solar day. And finally, in step 6, you will determine your pulse rate using a stopwatch. Record the data in table 2 and compute the average value. In step 1, we will determine the least count of the measuring devices and record the results in table 2.1. All right, so first we will determine the least count on the measuring stick. So here you have the meter stick. So we are going to use the metric side of the meter stick. So if you look carefully at the meter stick, you will see that the meter stick has major markings 1 to 100 centimeter. Now, in order to use the meter stick accurately, we need to figure out the smallest subdivision on the meter stick, which is known as the least count. So if you take any 2 intervals on the meter stick, say for example between 38 and 39, and you count the number of small divisions in between, you should get 10 small divisions. Now on the board, I'll be putting an equation to show you how to calculate least count. So take any 2 intervals on your meter stick, and I decided that I was going to take 38 centimeter and 39 centimeter. So it's the difference between the intervals. So least count is the difference between the intervals divided by the number of small divisions, and that was 10. right, so our numbers were 39 and 38. So I'm going to say 39 centimeter minus 38 centimeter, and then we are going to divide by 10. So the difference between 39 and 38 is 1.0 centimeter. And then we're dividing by 10. And that will give us 0.10 centimeter. Now, we know that 1/10 of a centimeter is equal to 1 millimeter. So here we can say that the numerical value for the least count on the meter stick is 1.0 millimeter. Now we're going to do the least count on the tripper beam balance. So here is the tripper beam balance. And as you can see, the tripper beam balance has 3 different scales. There's a scale in the back that you can measure masses up to 100 grams. There is a scale in the middle that can measure masses up to 500 grams. And then there is a scale in the front that can measure masses between 0 and 10 grams. Now, of the 3 scales, you will notice that only the scale in the front has subdivisions between intervals. So when we find the least count on the tripper beam balance, we will use the scale in the front. Now, in a similar fashion, you're going to take any 2 intervals on the tripper beam balance, and you are going to count the number of small divisions that are between the intervals, and then you will take the difference between the intervals and divide by the number of subdivisions. So here, if you follow me to the board for the tripper beam balance, the least count Alright, so on the we're going to choose the intervals 2 and 3 on the tripper beam balance. So here we will have 2.0 grams, so we're going to use 3.0 grams and 2.0 grams, and then there are 10 subdivisions between each. So here again, the least count will be 0.10 gram. So here we are going to record that the least count is 0.10 gram. All right, now we're going to do the least count for the stopwatch. To do the least count of the stopwatch. So here the first digit represents minute, and then the next 2 digits will represent seconds, and then the last digits will represent some fraction of a second. So now let us start the stopwatch, and you will note that if you look carefully, you will note that whenever the number reaches like 100, then the digits change. So basically, the least count on the stopwatch is 100 millisecond. And if we were to put that in seconds, then we would say 0.100 seconds. This count is 100 millisecond, and 100 millisecond is the same thing as 0.100 seconds. All right, so here we have least counts. Here we're just to put the numbers, and over here we need to put the unit of measurement. So if we're going to put 100 milliseconds or 0.100, so here for the meter stick the unit would be the millimeter. For the triple beam balance, the unit would be grams, and for the stopwatch, the unit would be seconds. All right, so we're gonna move on to the second part of step 1, where we will be measuring the length and width of our laboratory table. So if you notice, of course, the shortest side of the table is usually the width, and the longest side is the length. So the table is the width, and the longest side is the length. So first we're going to measure the length of the table, and then we will measure the width of the table. So I'm going to use the meter stick, and I'm going to make sure that the tip of the meter stick is at the tip of the table, and I will mark the first 100 centimeter because the meter stick isn't long enough to measure the entire length of the table. So this is 100 centimeter, and then I'll measure the next portion. Let's do this again. So here we have 100 centimeters, and then I'll measure the remaining portion of the length of the table. So the length of the table is 181, 2, and it falls between the 2 and the 3, so it's 182.50 centimeters. Now, in your whenever you measure anything using a measuring device, your last digit needs to be an estimated digit. So because it's exactly 182.5, my estimated digit will be 182.50. So I'm going to write that down on the board. The length of the table and then we're going to take the width of the table. So we're going to measure the short side of the table. And I'm going to mark where we have the first 100 centimeter. And then we have to measure the remaining portion of that. So we have 100, and this now is 6, 6.1, 6.2, 6.25. So it's 106.25. So the width of the table is 106.25 centimeter. Now, once we have the width and length of the table, we can find the area of the table in squared meter. So to find the area of the table in squared meter, so now we can find the area of the table in squared centimeter. So area equals length times width. And according to our measurements, the length of the table is 182.50 centimeter times 106.25 centimeter. Now I want you to put this number into your calculator and report the area to the correct number of significant digits. Now when you analyze the length and the width of the table for significant digits, you will see, according to the significant figure rules, that there are 5 digits in the length of the table, 5 significant digits, as well as 5 significant digits in the width of the table. According to the rules of multiplication, you will report the number of significant digits in your answer as there are the least in the numbers that you are multiplying. So both numbers have 5 significant digits, so the answer or the area of the table should also have 5 significant digits. Now I'll go ahead and put these numbers in my calculator. I have 182.50 times 106.25, and I will report this to 5 significant digits as 19,387 squared centimeter. So this is the area of the table in square centimeter. The final step in this procedure is for us to convert the area from square centimeter to square meter. So I'll just put this, I'll put this conversion here on this side of the board. So we are converting from square meter to square centimeter. Okay, so from our meter stick today, this is a meter stick, and on this meter stick there are 100 centimeter in 1 meter. So that is what we learned from our meter stick today, that in a meter stick there are 100 centimeters in 1 meter. So we want to start with that equality. 1 meter contains 100 centimeter. Now to go from squared centimeter to square meter, it means that we could square both sides of the equation. Now the exponent is basically telling you how many times to multiply the number. So it's telling you to multiply 1 meter 2 times. So we say 1 meter times 1 meter. And on the right hand side of the equation, we will say 100 centimeter times 100 centimeter. Now 1 meter times 1 meter is 1 meter squared. And then 100 centimeter times 100 centimeter is 10,000 centimeters squared. Now we want to convert this number, 19,387. So in order to do this, we're going to use a technique known as dimensional analysis. And in this technique, we're basically using the units to guide us in our conversion. So we're going to start with the given number, that's 19,387 centimeter. And then we're going to use this equality, and we're going to make our conversion factor where we will put the desired unit in the numerator. So the desired unit is square meter, so we're going to put 1 square meter in the numerator, and then we will put 10,000 squared centimeter in the denominator. All right, so basically it's as simple as multiplying and dividing. So you should recognize that 19,387 centimeter is in the numerator, and if you want to make sure, you can just put that number over 1. So here we're going to multiply what's in the numerator and then divide by what's in the denominator. Any number multiplied by 1 is the same number. So 1 times 19,387 is 19,387, and 1 times 10,000 is 10,000. Now let's look at the units for a second. Notice that we have centimeter squared in the numerator and centimeter squared in the denominator. So centimeter squared divided by centimeter squared cancels out. That gives us 1. And so we're left with the unit of square meter. So our answer is now in square meter. So let's do that division and see what we have. When we do the division, we should have 1.9387 square meter. All right, so we've completed step 1 of our experiment. In step 2, we will determine the volume of a wooden block in cubic centimeter. We will take three measurements of each dimension of the wooden block and record all significant digits in table 2.2. So to do this, then we're going to use 3 different wooden blocks. I'm going to take the length, the width, and the height. Now, of course, the length is the longest part of your wooden block, and of course you all know that wooden blocks are 3-dimensional. So I'm going to take the length, the longest side is the length, and then the height would be okay, so the height would be here, and then the width would be one of the shorter sides. So I'm going to measure the length of the wooden block in centimeter. So the length of this wooden block is 5.10 centimeter, and I'm going to make a note of this on my paper, and then I will later record it in table 2.2. So the length of wooden block is 5.10 centimeter. Now I'm going to take the width of the wooden block and the width of the wooden block is 5.10 centimeter. Now I'll take the height of the wooden block. So I'm going to measure the height from the table to the edge of the wooden block. So this height is 1.10 centimeter. So the height of the wooden block is 1.10 centimeter. Now we are to take 3 measurements of these dimensions. I'm using 3 different wooden blocks of the same size. So I'm going to go ahead and see what is the height, the length, the width, the length and width and height of the remaining 2 wooden blocks. So I'm taking the measurement again. And this one is 5.09 centimeter for the height. And then for the width, it's the width is 4.8 centimeter. 4.8, sorry, let's do that again. The width is 4.80 centimeter, and the height is the height is 1.10 centimeter. All right, so now we will do the third block. Again, we are going to repeat the dimensions. So first I'm going to take the height and then the width, and sorry, I'm going to take the length. First I'm going to take the length, and this length is 5.05 centimeter. The width is 4.5 centimeter. And then the height is 1.00 centimeter. All right, so now I'm going to go to the board and I'm going to record these data in table 2.2. So let's go. Here we're going to record the data in table 2.2. So we did 3 different trials of the length, width, and height of the table, and I'll record these results in table 2.2. So here we have 5.10 centimeter, and then the width is also 5.10 centimeter. The height is 1.10 centimeter. For the second one, the height is 5.09 centimeter. The width is 4.80 centimeter, and the height is 1.10 centimeter. And then for the third block, the length is 5.05 centimeter. The width is 4.50 centimeter, and the height is 1.00 centimeter. Now we are going to use the formula volume, and since we're finding the volume of the block, I'll put V sub block equals length times width times height. Now, before we can do this, we need to find the average value of the length. All right, so to find the average of a given set of numbers, you will sum the numbers and divide it by the number of measurements. So first we're going to add 5.10. So we're adding 5.10 plus 5.09 plus 5.05. And then we're going to divide that by 3 since we took 3 measurements. And I've gotten 5.08, so that's the average. 5.08 centimeters, so the average length is 5.08 centimeters. Now I'm going to do the same thing for the width. I'm adding these numbers and then I'm going to divide by 3. So 5.10 plus 4.80 plus 4.50, and then I'll divide it by 3, and the average width is 4.80 centimeter. Now the average height, I'll add these 3 numbers and divide by the number 3. So here I have 1.10 plus 1.10 plus 1.00, and then I'll divide by 3, and I have 1.07. Now I'm ready to calculate the volume of my block. So the volume of the block is equal to 5.08 centimeter times 4.80 centimeter times 1.07 centimeter. So I'm going to go ahead and put those numbers in my calculator. So I have volume of the block equals length times width times height. So I'm going to say 5.08 times 4.80 times 1.07, and that will give me 26.1, and then centimeter times centimeter is squared centimeter times centimeter is cubic centimeter, so my unit is cubic centimeter. So the volume of the block is 26.1 cubic centimeter. So the volume of the block is 26.1 cubic centimeter. All right, so we've come to the end of step 2, and now we will begin step 3. In step 3, we are going to determine the mass of the block. So here is our balance, and we are going to use our triple beam balance, and just to kind of teach you how the balance works. So here we have the pan. We will put our object in the center of the pan, and then we will move these weights until it is centered here. So the mark that is here will be centered with the mark that says 0. So here I'm going to take the mass of this block, and notice right now, if you notice, the lines are not balanced, so we will have to move things around until we get these 2 lines to match up. So let's start with the scale at the back. So let's see if our block is 40 grams. So our block is less than 40 grams, and that's why the line has gone below the 0 point. So let's move it back to 30 and see if it goes below. It goes below again. Let's move it to 20. Let's move it to 10. Okay. Let's put it back to 0. So the block is lighter than 10 grams, so we will have to use the scale in the front. So let's move the scale in the front. Let's try to see if it is 5 grams. All right, 5 grams is too low, so let's move it back up to 7 grams. Let's move it to 8. Let's move it to 9. Let's move it to 10. All right, so obviously it's heavier than 10 grams. So let's move this one again. Okay, and then we're going to move this block here to see if the balance moves. Okay, so it's somewhere between 15 and 18. So let's bring it to 17 and see what happens. It's getting closer. So right now it's at 17.10. Let's see. It's almost there. We have to be gentle. And I think we have the lines lining up. So we can read this as 17.90. So the mass of our wooden block is 17.90. So I'm going to record that on the board. Mass of wooden block is 17.90 grams. Now the next thing that we will do, we will determine, in step 3, we will determine the density of the wooden block using the formula density equals mass over volume. So here the volume of the wooden block was step 2. The mass of the wooden block is step 3. And in step 4, we will determine the density of the wooden block. So we're given the equation that density equals mass over volume. And from our experiment, the mass of the wooden block was determined as 17.90 grams. And the volume was determined to be 26.1 cubic centimeter. So when we put those numbers in the calculator, we can say that density equals mass over volume. So we're dividing 17.90 by 26.1. So 17.90 divided by 26.1, and that gives us 0.686 grams per cubic centimeter. Now, notice I record my answer to 3 significant figures because the mass of our block has 4 significant figures. The volume has 3, so your answer should also have 3 according to the rules of division. And notice the units are grams per cubic centimeter, so that's the unit for the density. So the density of wooden block All right, so we've come to the end of step 4, and we will then move into step 5. 5 of our experiment, we will express 1 second as a fraction of a mean solar day. So in order to do this, we have to bear in mind that 1 minute equals 60 seconds, and 60 minutes equal 1 hour, and 1 hour equals, and 1 day equals 24 hours. So we can use these 3 equalities to convert 1 second as a fraction of a solar day. So we can say 1 second equals, we can say 1 second we can say 1 second, and then our first conversion factor, since we are going to go now from seconds to minute, we will put 1 minute in the numerator, 60 seconds in the denominator. And then in our second step, we're going to convert minutes to hour. So we are going to make another conversion factor where the desired unit goes in the numerator, and that's going to be 1 hour. And then 60 minutes will be in the denominator. And then in our final step, where we're converting seconds, so in our final step where we're converting hour to day, we will put day in the numerator, which is 1 day, and we will have 24 hours in the numerator. Now, notice, let's look at the units for a minute. So here, second cancels, because you have second in the numerator and second in the denominator. Minute cancels because we have minute in the numerator and minute in the denominator. Hour cancels because we have hour in the numerator and hour in the denominator. So the only unit we're left with is the day. Now we are going to multiply what's in the numerator and then divide by what's in the denominator. So now we can say 1 second is equal to, so 1 times 1 times 1 times 1 is 1. And when we multiply 60 by 60 by 24, we're going to get 86,400. So let me double check that number, making sure. 60 by 60 times 24, and we get 86,400. And this is our original definition of the second. 1 second is a fraction of a mean solar day, which is 1 over 86,400. So this is how we express the second as a fraction of a mean solar day. So what they're saying, we're done. In step 6, you will determine your pulse rate using a stopwatch. You are to record the data in table 2.3 and compute the average values. Let's begin. Right, that's 1 minute. All right, so we have 62 pulse per minute, and you are going to do yours at home, and you will get 2 additional readings. So I'm going to draw up table 2.3. That's where you will record your pulse. I'm going to put my pulse rate in table 2.3, and then you will get 2 additional readings. So here we have trial 1, trial 2, and trial 3. And then here you will put pulse rate, or pulse per minute, which is the same thing as pulse rate. All right, so the number for trial 1 is 62 pulse in 1 minute, and then you will get 2 more data sets. You can use your cell phones as a stopwatch or as a timer to get this part of the lab done. So you're going to do the other 2 values. All right, so I want to thank you for watching this video, and I'll see you next time in lab.